I am Mohanlal Pereira from Study Guide. Today I am going to discuss about relative velocity. Relative velocity 100 out of 100. There is a simple technique which we used in relative velocity which can ensure that we can get 100 out of 100 in exams. Relative velocity. The velocity of a moving object related to another moving object is relative velocity. It can be described as how a moving object is seen by another moving object. Velocity of A relative to B is equal to velocity of A relative to Earth plus velocity of Earth relative to B. This is the velocity triangle rule. Crossing a river. A river named R has parallel straight banks. It flows at a uniform velocity u. The width of the river is d. A person named P, who can swim at a uniform speed v in still water, crosses the river. Now the general situation. In this diagram, river flows from top to bottom. The person crosses the river with v velocity at a alpha angle to the river bank in the opposite direction of the flow of the river. So by velocity triangle rule, velocity of the person relative to earth is equal to velocity of the person relative to water plus velocity of the water relative to earth. Now it is equal to v plus u. V is at an alpha angle from the opposite direction of water flow and u is straight away along the water flow. Now, the velocity across perpendicular to the water flow is going to be v cos 90 minus alpha, that is v sin alpha. Therefore, the time taken to cross the river is going to be d divided by v sin alpha. Velocity along the river is going to be u minus v cos alpha. Now the first case, v is greater than u, which means the person can swim faster than the river. This could be given as v equals ku, where k is a positive constant larger than 1. Now consider crossing perpendicular to the river. If he wants to cross perpendicular to the river, downward velocity should be 0. That is, u minus v cos alpha equals 0. Cos alpha is going to be u over v. Since v is greater than u, cos alpha is less than 1, which means there's a valid alpha, that is, the person can cross perpendicular to the river. Now the time taken for crossing is going to be d over v sin alpha. When we draw a rectangular triangle where cos alpha is u over v, sin alpha is going to be square root of v squared minus u squared divided by v. So d is going to be square root of v squared minus u squared. This is the time taken for minimum distance of swimming. Minimum distance between two parallel lines is the perpendicular distance. Now, crossing in minimum possible time. The time taken for crossing is d over v sin alpha. So, to get the minimum time, sin alpha has to be maximized. That is, sin alpha is equal to 1. So, alpha is 90. He should aim perpendicular to the river and swim. Then only he can swim at a minimum possible time. So the minimum possible time is d over v. The velocity along the river is u minus v cos alpha. Since alpha is 90, cos alpha is 0. So the velocity along the river at this time is u. So he will be drifted u into d over v distance downward along the river. So if a person wants to cross in minimum possible time, he has to aim perpendicular to the river and swim. And the minimum possible time is going to be d over v. When he swims, he will be drifted u d over v distance downward along the river. Now the second case. V is less than u. That is, the person cannot swim faster than the river. This can be given again as v equals ku, but in this case, k is a positive constant less than 1. Now, to cross perpendicular to the river, v should be 0, that is the downward velocity should be 0. In that case, we get again cos alpha is u over v, but since v is less than u, cos alpha is greater than 1. So we don't have a alpha which matters this situation, which means the person cannot cross the river perpendicular to the river. Right. Now we want to find the minimum time taken to cross the river and the drift downward. The person's speed relative to river is a constant. It describes a circle of radius v. Now we can draw this as the diagram given. So in this diagram, the person swims alpha angle to the upward river. So the width of the river is d as usual. The time taken for crossing this distance is d over v sin alpha. To cross in minimum time, sin alpha should be maximum. So sin alpha is equal to 1. So alpha is 90. Right? So he should aim perpendicular to the river and swim, just like the earlier case. Minimum time is going to be d over v. He will be drifted u d over v distance downward along the river. These values are same as the previous case, but of course he cannot swim perpendicular to the river. Now we are going to find the time taken to cross the river with minimum distance and the downward drift at that time. We know the width of the river is constant, and to cross the river with the minimum distance, the drift downward should be minimized. This can be done when the person's velocity is relative to Earth should be a tangent to the previous circle. This situation is drawn in the diagram. Now we can see all other codes drawn from the starting point are going to be larger than this tangent. So this tangent gives the minimum distance. Width of the river is d. Time taken to cross this distance is d over v sin alpha. Cos alpha is u. Cos alpha is v over u. So sin alpha is square root of u squared minus v squared over u. So the time taken is ud divided by v square root of u squared minus v squared. The downward velocity is u minus v cos alpha. So the drifted distance downward along the river is going to be u minus v into v over u into ud divided by v square root u squared minus v squared. That is the time taken. Now when we simplify this, we have to take u as the LCM, then you will have u squared minus v squared divided by u. That u can be divided by the u in the numerator, and the final result is going to be square root u squared minus v squared into d divided by v. So again, if the person has to cross the river with the minimum distance, the direction he goes, that is the velocity of the person relative to the earth, should be a tangent to the circle. Now velocity triangles. We have drawn velocity triangles, but there's another skill, that is to draw velocity triangles of two relative motions in one diagram. Skill of drawing velocity triangles of two relative motions in one diagram is necessary. This skill is questioned regularly in exams, so if you want to get 100 out of 100, it is very necessary to get this skill properly. In such situations, there will be a constant velocity, which is the common side of the triangles. So we are drawing two triangles. The common side will consist of the constant velocity of both of these relative motions. Then there will be a constant speed. That is, the speed is same but the direction changes, which is represented by a radius of a circle. So easiest thing is to start with the velocity triangle using the common side. We draw the common side at the beginning. Examples of these situations: crossing a river upward and downward. That is, you swim upward on the river as well as downward on the river. Then piloting an aircraft from one airport to another airport and returning back to the previous airport when there's a constant wind is blowing. Cycling up and down on a road, again when there's a constant wind blowing. Now we are going to discuss a typical example. An aircraft can fly at a speed of u kilometers per hour in still air. There are two airports A and B which are s kilometers apart. AB makes theta from north to west. A wind blows at v kilometers per hour from north. The aircraft flies from A to B and returns to A without stopping. Now draw two velocity triangles in one diagram for both flights and show that: part 1, the aircraft should be directed at an angle sine inverse v over u sine theta to AB in both flights. Second one, the total time taken for the flight is 2s into square root of u squared minus v squared sine squared theta over u squared minus v squared hours. Now first of all, we'll draw how this flight occurs. Now from A, the pilot has to direct the plane having an alpha angle to AB, and there will be the wind downwards or southwards at A. Then at B, the pilot should direct the plane beta angle to BA. As usual, the velocity of wind will be towards south in the same direction of the previous case. Now we can apply velocity triangle or relative velocity rule for the flight from A to B. Velocity of the aeroplane relative to Earth is equal to velocity of the aeroplane relative to wind plus velocity of the wind relative to Earth. This velocity is taken as v p1e, it is u plus v. U is directed having alpha angle with AB. V is towards south. Then flight from B to A. We can apply the same relative velocity rule. Velocity of the aeroplane relative to Earth is equal to velocity of the aeroplane relative to wind plus velocity of the wind relative to Earth. That is taken as v p2e. Again it is u plus b, but the direction of u is beta angle from B to A. V is again southward. Now the velocity triangle. This diagram shows the velocity triangle. We can start drawing V, then we can have two U's which makes beta and alpha angle to the direction of AB. We have to note that Vp1e and Vp2e are in the exact opposite directions. Vp1e from A to B, Vp2e from B to A. Now we can use the sine rule for the flight from A to B. That is the rightward smaller triangle. So we have u over sine 180 minus theta is equal to v over sine alpha is equal to v p1e over sine theta minus alpha. Then we can apply the sine rule for the flight from B to A, that is the leftward bigger triangle. Then we get u over sine theta equals v over sine beta, which is equal to Vp2e over sine 180 minus theta plus beta. Since sine 180 minus theta is sine theta, we get u over sine theta equals v over sine alpha, which is equal to v over sine beta. Thereby we get alpha is equal to beta. That is, the flight is directed at the same angle to AB when it goes from A to B as well as B to A. So sine alpha is going to be v over u sine theta, that is alpha is equal to sine inverse v over u sine theta. Now when we consider the flight from A to B and previous sine rule, we get Vp1e equals u sine theta minus alpha over sine theta. Then when we consider the flight from B to A, Vp2e is u sine theta plus beta over sine theta. Since beta is equal to alpha, this becomes u sine theta plus alpha over sine theta. Now the total time, s divided by v p1e plus s divided by v p2e. That becomes s sine theta over u sine theta minus alpha plus s sine theta over u sine theta plus alpha. Now s sine theta over u is common and the LCM is going to be sine theta minus alpha into sine theta plus alpha. Then we can apply the sine addition rule in the numerator and the product rule in the denominator. So the numerator becomes 2 sin theta cos alpha and the denominator becomes cos 2 alpha minus cos 2 theta over 2. So cos 2 theta is 1 minus 2 sin squared theta. Cos 2 alpha is going to be 1 minus 2 sin squared alpha. When you simplify that, the denominator becomes sin squared theta minus sin squared alpha. Now we can substitute for cos alpha as well as sin squared alpha. Since sin alpha is v over u sin theta, then you substitute and simplify. Then finally we get 2s over v squared minus v squared sin squared theta square root divided by u squared minus v squared. This comes in hours. When you simplify this, you will have to be a little bit careful because there are a lot of common things coming in the numerators and the denominators. We can simplify them very easily. So this is the answer which is given in the question. Right. So this is one way of getting this total flight time. I am going to discuss another method to get this total flight time. Second method. We can use the same diagram here, and the total flight time is going to be s divided by v p1e plus s divided by v p2e. Now when we simplify this by taking the LCM, we get s into v p1e plus v p2e divided by v p1e into v p2e. Now v p1e is the velocity component along AB. So we have to resolve u and v along AB. So v p1e is going to be u cos alpha minus v cos theta. Similarly, v p2e is going to be u cos alpha plus v cos theta. When we add these two equations, we get v p1e plus v p2e is equal to 2u cos alpha. So sin alpha is v over u sin theta. Cos alpha is going to be square root of 1 minus sin squared alpha. When we substitute it and simplify, this becomes 2 times square root of u squared minus v squared sin squared theta. Now when we multiply these previous two equations, we get v p1e into v p2e. These two can be considered as difference of two squares. So we get u squared cos squared alpha minus v squared cos squared theta. So for cos squared alpha, again we can write 1 minus sin squared alpha and simplify. So your cos squared alpha is going to be u squared minus v squared sin squared alpha over u squared. So when we simplify this, it becomes u squared minus v squared. Now the total time taken or the total flight time is 2s u squared minus v squared sin squared theta square root divided by u squared minus v squared. Thanking you. This is brought to you by Study Guide. Hoping your education will be an enjoyment.